Hey guys, I decided to start learning assembly, and it was interesting. I need to explain a few things first, however, and we'll start with registers. Registers are tiny, extremely fast pieces of storage inside the CPU that holds the data the processor is working with. They should not be confused with RAM, which is slower to work with and is located outside the CPU. They can be used to hold values, store memory addresses, and pass arguments to system calls/functions. The fact that the CPU can access them almost instantly is why they are fast and everything important goes through them if possible. There are different types of registers, separated by width among other things. That's not relevant for this video, however, and the only thing you need to know is that we are going to be working with 64-bit registers, which are 64 bits wide and can hold 64 bits at a time. We can do operations like move and add on a register. Move, moves a value into a register, which we are going to be using a lot. There are other operations, but they don't matter for this video. Now for some actual code. We'll cover Hello World in this video. First, we need to define data for our program. We can do this by using section.data. We'll define our message as hello, which contains the string hello world, followed by a new line character. 10 is the new line character / byte here. Then we can figure out the length of hello by using a pointer to the star of hello subtracted from our current memory address, which gives the length of hello in bytes stored in lin. We can then write some more boilerplate using section.text. This is where we tell our program we have a global start label. The global just means we're exposing it to the linker so it knows it is the entry point of our program. You can think of it like the main function in C. We can now put code into the start label. We'll start by putting a value into the racks register, which tells the OS which type of operation we want to perform. In this case, we want to do syswrite, which means we need to move the value 1 into racks. The registers RDI, RSI, and RDX are further arguments for what we want the OS to do. We put the value 1 into RDI to signal to the operating system we want to do standard output, the pointer to the star of hello and RSI to signal where the output should start, and then into RDX so the OS knows the number of bytes to output. We then do syscall to execute these instructions. If we are to assemble the program into an object file and then use the linker to convert it into an executable, we can run the program. When we do this, we get our desired output of hello world, but we also get a segmentation fault since the program didn't know how to exit and kept continuing until it inevitably hit memory it wasn't allowed to touch. We can fix this by explicitly exiting the program. We do this by putting the value 60 into racks after doing our first syscall, which signals we want to do a sysexit. We then put the value 0 into RDI to signal successful completion. We then do another syscall in the code to execute these instructions. After going through the necessary steps again, we get our output of hello world, but this time it isn't followed by segmentation fault. That's a basic assembly program for you all. Make sure to like, subscribe, and leave a comment. Till next time, bye.